second says the absolute value of x minus 2 is less or equal to 3. Third one says the absolute value of x minus 2 is greater than 3. This is a 2.5 preview. Still a preview of some of this in 2.5. Now, we make this really simple when we understand that the absolute value of x minus a is the distance from x to a on the real number line. So I'm going to draw a real number line here, perfectly straight as always. Here's 2. Need to make it a little bit longer. Looks like -1's a key spot there. And look at what this first problem is saying. It's saying that the distance from x to 2 has to equal 3. So 2 is right there. Where is x allowed to be? Who's up first, Thomas? Hit the button. Josh. What number? Where can we be on this number line so that, imagine you walking along the number line, okay? Where can you be so that your distance from the number 2 is exactly 3?
Either 5 or
I agree. So the answer to this is x is -1 or x is 5. Solved. There's the graph. Okay? Josh, where can we be on this number line? Describe it in English terms, just any way you want. Describe to me where I can be on the number line if I'm at x and my distance from 2 is less than or equal to 3. Yeah, my distance from 2 has got to be less than or equal to 3. It's like I'm a dog on a chain, and I'm chained up at 2, and my chain is 3 long, and I can wander along the number line, but snap, I can't go past certain distances. Where can the dog be?
anywhere from 5 down.
Anywhere from 5 down, forever? Yeah. Really? Back
No,
here, I got to be less than 3 away. Here I'm like 100 away, 1,000,000. Well, 12. Where can I be? My distance from 2 has to be less than 3. I can't get to the right of 5, can I? What can't I get to the left of? You told me that -1 was 3 away from 2. So -1. So my answer here is -1 is less or equal to x is less than 5. And to graph it in red, there would be the red graph. Because it says the distance from 2 is less or equal to 3. Now, you pick any number from -1 to 5, subtract 2 from it, and your absolute value is going to be less or equal to 3. If we pick -1 and put it in here, -1 minus 2 is -3. The absolute value of that is 3. It works. Put 5 in here, 5 minus 2 is 3. The absolute value is 3. It works. Any number in between, you take the absolute value, it's less than 3. And so, who's up next? Thomas? Elizabeth. What's the solution to this one? Where can x be if its distance from 2 has got to be more than 3? It's like, stay away from me. Stay away from me. At least 3 away from me. Where can it be? Here's me. Stay away from me. Be at least 3 away from me. Where can you be?
6.
6 is good. -2 is good. Is that it? Just those spots? Okay, what about 5.01?
Yes.
Okay, that's a big SAT error. Is that students get in their mind that numbers have to be integers. And they say 6, 7, 8, but it could be 5.01. So the answer is hash 5 this way, or so we say x has to be less than -1, or x has to be greater than 5. Now I will show you a couple other techniques for doing those problems. But that is the technique that if you, all you have to do is remember this and understand physical stuff, and I know that's hard for a lot of students, but if you get this physical understanding of this piece of mathematics down, these problems are just trivial. They're trivial. That's a preview. Okay, 8 problems. I'm going to put 8 problems on the board. It's going to take me a second. You'll get them both in time. Don't worry about having them all at once. And I want you all to be anticipating what the answer is to each one of these 8 problems. They're going to look pretty pretty typical. I'm gonna just, I won't use these numbers. I'm gonna go with x is greater than -2, or x is greater than 3. Okay, 4 problems. X is greater than -2, and x is greater than 3. Okay, now I'm going to go with x is greater than -2, or x is less than 3. X is greater than -2, and x is less than 3. Okay, I blew those up real good. Let's go with black. Let's go now with x is less than -2, or x is greater than 3. X is less than -2, and x is greater than 3. What am I left with? Anyone know? X is less than -2, or x is less than 3. X is less than -2, and x is less than 3. 7 problems. I'll number them. Number 1, number 2, number 3, number 4. Number 5, number 6, I should say 8 problems. 8 problems. So they are 8. I said 8 at the beginning. 8 problems. Okay, in each case, I just want to graph the solution and give the simplified algebraic expression for it if possible. Okay, who's up?
Bailey.
Bailey. This first one is probably really, really hard. So you can handle it. Final answer. I want numbers that work. I want all the numbers that work, not just the one. I want the solution set. I want all numbers x on the number line. Here's -2, here's 3. Those are clearly the key numbers. I want you to tell me what numbers work here. The numbers have to be greater than -2, or they have to be greater than 3. What numbers work?
Any number is greater than -2.
Excellent. The calculator picked the right person there, because this is usually missed. Okay? The final answer, x is greater than -2. It's redundant to say, or x is greater than 3 for final answer. We want numbers that are either greater than -2 or they're greater than 3. That didn't contribute to our solution. We were happy with this group. That's the group. Excellent. Okay? I'm going to give you one more. Number 2. We changed the problem, or changed to and. English language and, it's the and you've been using your whole life. Do this and do this, and. Okay? What numbers work for the second one?
Any number is greater than 30.
Correct. So 0, 1, 2, 3, open circle. Why can't we pick numbers back here like 0?
Because they're less than 3.
Yeah, they had to be greater than 3. They had to be greater than 3. And they had to be greater than -2. It turns out that wasn't very helpful. Okay? We have 8 different possibilities when I switch to 8. See, I got 2 choices for this, whether it's less than or greater than. 2 choices for this, whether it's or and. 2 choices for that, whether it's less than or greater than. 8 different ways to make this problem. All 8 of them are here. Who's next, Thomas?
Alyssa.
Okay, you said Alyssa?
Yes.
Okay, listen, number 3. We need numbers that are greater than -2 or less than 3. What's the solution?
Well, it has to be. They're less than -2.
It says x has to be greater.
I mean, between -2 and 3.
It says or. It says or.
So it has to be.
Okay, you know what it's like? It's like the problem we had yesterday where we said to be in the Tim Schafer Club, you have to be more than 3 years old, or you can be less than 70 years old. Who's in? Who's in? More than, I'm going to change it. More than 11 or less than 12? Who's in? Everybody. We need numbers that are greater than -2 or they're less than 3. What's in? Alyssa, answer. Everything. Everything's in. All real numbers. It's like, what a nice, friendly problem. Everything works. Every number is greater than -2 or less than 3. There's no exceptions. Now, Alyssa, I think you were, in your mind, doing and. It's
Yeah.
very common, so you're lucky you get to do and now. What's the solution to the and problem?
It's anything between -2 and 3.
That's correct. And she said anything between -2 and 3,
Not
Yeah, right.
including.
not including the endpoints. So we write that algebraically with the between notation. -2 is less than x is less than 3. That's how we write between problems. So I'm starring this one because that's a real common problem to be asked at. It's real common. 2 of these are common, the other 6 are not common. This is one of the common ones. Who's up next, Thomas?
Kyle.
Kyle, number 5.
So would be anything that's not between -2 and 3? Or
Now, say that again.
anything that's
Say
not,
exactly what you said before.
anything that's not between -2 and 3.
That's true. Okay, but it's also not -2 and 3 either. So how do I graph it?
It would be a open circle at -2, and it would be going to the left.
Squiggle that.
Yep, and an open circle at 3, squiggle to the right.
So this is the other classic problem. This is called a conjunction, 2 pieces together. This one's called a disjunction. They're not joined. And that's the other classic problem. Okay, interesting. How about number 6, Kyle? Number 6, you get to do 6 too. What do I graph?
One sec. So it would be,
I want numbers that work. To be in my club, this is more like me here. You got to be less than -2, and you got to be bigger than 3 to be in my club.
it's not possible.
I'm not even in my club. There's no answer. Empty set. Next one,
Joseph.
Joseph, number 7.
Okay, so we're gonna have the number line from -2 to 3.
What gets shaded in? What works?
Now
What
we're gonna have
belongs?
an open circle on -2, and it's going to be going to the left, scroll to the left. And then an open circle on 3, and that is also going to the left. So it's x.
Now, hang on, interesting. He just showed us his thought process as he went through. He didn't give us the final answer. He just said, look, x is going to be less than -2, so these are good. Or x is less than 3, so these are good. So now, net result,
X is less than 3.
x is less than 3. A very similar problem to number 1, just going the other direction. It was an or. It was redundant to say, it's like, you know, to be in my club, you have to be less than 17 years old, or you can be less than 11 years old. And did you really need the second part? No. You have to be less than -2 or less than 3. This is enough. Less than 3, this has no information. It's unnecessary. It's redundant. Okay, and the final one? Go to the final answer, the final one.
It's less than 3, or less than 3. X is less than 3.
Same as before, same answer you're saying? Just like these are the same answer? And an or is not going to get you the same answer very often. We need the numbers to be less than -2, and they have to be less
Oh,
than
I
3.
mean, less than -2, right?
It's just less than -2. So the final answer, x is less than -2. So most problems you get in the test are going to be of these 2 types. Every once in a while, one of the others gets thrown in. The next most common would be everything works, nothing works. There's other problems that are sort of silly, but it's real life. You get situations where you're given additional constraints and they just don't add anything to the problem. They don't matter. Okay, so now we're backing up to 2.2, and we have 2 very difficult problems right at the end of the lesson that we're going to work through, and with your help. Who's up?
Elizabeth.
Elizabeth, 35. Pretty challenging to read this one. Let's see how you do it. 2.2 is on page
68. 2 is less than y plus 6 over 2 less than 5, and 4 minus y is more than 5, or 4 plus y is more than 7.
Is that right?
It's in parentheses.
What's in parentheses?
The whole right equation.
Just this?
No, the whole thing.
Last two, but around the or?
Yes.
Okay, and it's important because actually you have a please excuse my dear Aunt Sally. You have a similar thing with ands and ors, and ands are evaluated before ors unless you have parentheses. So the parentheses are forcing us to do the or first. Otherwise, we do the and. And works like multiplication or like addition and high-end stuff that we'll learn a little bit of. Anyhow, okay, we're going to try to clean this up and come to a final answer and have the simplest, most concise algebraic expressions we can at the end. And so right here, do what, Elizabeth? We want to isolate this y in the middle. It's in the middle. Y is between stuff, so we want to isolate it. To get the y alone, we